This video is on the zeros form of the quadratic function, which has other names. It's also known as the intercept form, and it is also known as factored form. And this is what it looks like. It's got an a in front and then two brackets, x minus p times x minus q. So you might be thinking that this doesn't look like a quadratic function because it doesn't have an x squared, but in fact, these brackets, when you FOIL them, if you distributed, you would get an x squared term. So it's why it's a different form. It looks different, but it actually is still a quadratic function. So a couple things that I'm going to take you through in this video. One is how to graph, and the other one is how to convert, but only part of the story for converting. So how would I graph something like this? Before I get to that, just to highlight a couple of things. This a value, the a value in front, is not only does it do the same thing as the a value in the other forms, it is actually the same numerical value. It's always the same. So no matter what form I convert to, this parabola, this function, has an a value of 2, positive 2. That's something that's important. And these values here, they tell us what the zeros are, but there are fixed negatives in this format here. It's x minus p and x minus q. So you're subtracting the two zeros. What that actually means is that in this case, the two zeros are -7 and +1. So kind of like the h value, it's opposite what is written there. -7 and +1 of the zeros. So how does that help us graph? Well, we can graph the zeros right away. I can graph 1 and -7. Notice that 1, I've included a scale on my axes, and 2, this one might seem like a weird scale, but that's because I know what my next point is going to be already. I've already taken that into consideration. I'll show you in a second. The zeros here are -7 and +1. I graph those right away. And then you need at least one other point. If you use the vertex, then having 3 points is sufficient when you're graphing this method. So the vertex is a good one to use. How do I find the vertex? Well, because this is symmetric, it's the same on both sides, I know that these two zeros, which have the same y value, they have to be equidistant. They have to be the same distance from the center, which happens at the h value. It means that h is halfway between the two zeros. How do I find that? Well, I can count from both sides, or I can just take the two zeros and add them and divide by 2. That's the method for finding the midpoint, or halfway between two things. -7 plus 1 divided by 2. All that is -6 divided by 2. That's -3. It means that my h value is -3. And I can find the k value. We've seen this in other cases. I can find the k value by just plugging in the h into the function. So I've got this function. I'll just replace the x with -3. In this case, when I'm plugging it in, there are 2 places to replace the x with -3. And I'll simplify each bracket and solve. -3 minus 1 is -4. -3 plus 7 is +4. I'll multiply all 3 numbers, and that is -32. So that is my k value. It means my hk is -3, -32. And if I were to plot that, it would be at -3, and -32 is down here. That's why I chose a scaling of 4. And then I can connect the dots and draw my parabola, even though that's not perfect. And the last thing that I wanted to go through in this video is converting. How to convert from general form to zeros. So we'll talk about the other forms afterwards. So one way to do that, we'll talk about another way in a different video. One way is to factor. So this is a trinomial. If I am able to factor this trinomial, and this one is factorable, it factors this way, that means that this is my zeros form. It means that the two zeros are +3 and +5. So that's one way to do that. And here's another example where there is a GCF. So if there is a GCF, I would take that out first, just like regular factoring. I'd remove that and then factor this trinomial. You can pause if you'd like to try. I'm just going to go ahead and show the answer. So this one here would have an a value of -2, and the zeros would be +6 and -3, and that is zeros form. And one final example, and if you want to take maybe an opportunity to try this on your own, you can pause the video and see if you can factor this. I'll just skip ahead to the factored answer. This factors this way, and though this is factored, this isn't factored form. The factored form, or the zeroed form, or the intercepts form has an a value in front, and in the 2 brackets, it's always x by itself minus the 0. So the fact that this has a 5 here means this isn't yet in the correct form. I have to take this 5 out. And to do that, I have to divide both of these by 5, or factor out of 5, even though 3 isn't really divisible by 5. I'd have to write it this way. So just to show you that in the proper final form, you should have an a value outside, and both of these have to be just x, even if that means that the zeros themselves are not integers. That's it.